In today's lesson, we're going to review exponent properties and also scientific notation. So first of all, let's go ahead and talk about how we apply the properties of positive and negative exponents. Remember, earlier this year, we learned about multiplying exponents. And remember we said that when you're multiplying exponents with the same base, we actually end up adding the exponents. So let's put the rule as adding. We add. And let's show how that works. So I have a to the third times a to the fourth. And what that means is that I've got 3 a's and then it's combined with 4 a's. If I go and I count up all the a's, I have 7 a's. Whereas if I have 2 4's and I have 5 4's and I combine them all together, I have 4 to the 7th power. Now, you could go ahead and you could evaluate that even further. For today, we're just going to leave these as the exponents. All right, so now when we divide exponents, remember division is the opposite of addition. So if we add the exponents when we're multiplying, we're going to divide by subtracting our exponents. So you're going to subtract. So for example, if I have a to the 6th divided by a squared, that means that I've got these 6 a's on the top and I've got 2 a's on the bottom. Well, 2 sets are going to cancel out, meaning I could take 6 minus 2 and I'd have a to the 4th power then. Now, if I had 5 to the 6th power divided by 5 to the 4th power, that means I have 6 5's on the top and I've got 4 5's on the bottom. Well, we're going to subtract out 4 of them, leaving you with 5 squared, or you could say 25. Either way is just fine. All right, so when we have negative exponents, remember that we said to make a negative exponent a positive exponent that we take the reciprocal or we end up flipping it. It's just a lot easier to write flip than it is to write the reciprocal. So what happens if I have a to the negative 3 power? I'm going to then, to make that negative 3 a positive 3, what happens is that this comes to the bottom, and then I have to have a placeholder on the top, meaning I'm going to have 1 all over a to the 3rd. And the same thing if I have 3 to the negative 2 power. Well, to make that a positive, I'm going to flip it, making it 1 all over 3 squared, or I could say 1 all over 9. Either one is just fine. And I guess I could have put 25 here. I feel like the 4 to the 7th power is going to be a really big number, so I'm going to avoid that one. All right, and then the last thing that we had done when we were talking about the exponents is that we said to have a 0 exponent, it is always going to be equal to 1. It means that all of the exponents or all the either variables or all the numbers have canceled out and just leaving us with a 1. So anything to the 0 power equal to 1. A to the 0 power equal to 1. 5 to the 0 power equal to 1. All right, now that we've reviewed the exponent rules, let's talk about what happens when we've got these negatives that are in front of the exponent. This is different than a negative exponent. This is a negative number with an exponent. And it's really important for you to notice the difference between number 1 and number 2. Number 1 has a negative 2 to the 4th power without the parentheses. And number 2 has a negative 2 with parentheses to the 4th power. So remember what we need to do here is we need to take 2 to the 4th power first. We have to follow the order of operations. So 2 times 2 is 4, 4 times 2 is 8, and then 8 times 2 is 16. So we would have then a 16, but then we have to place a negative back on. So this one is a negative 16. Where when you have a negative 2 that's in parentheses to the 4th power, that's like having negative 2 times negative 2 times negative 2 times negative 2. Well, 4 negatives end up making a positive 16 then. Now, if I had a negative, and then in parentheses 2 to the 4th power. That means I've got to evaluate this one first. So 2 to the 4th power is 16. And then we're going to put the negative back on it. Notice the difference between number 2 and number 3. The negative is in the parentheses, and then you've got the exponent, where the negative is outside of the parentheses. So you've got to evaluate that part first. And then for question number 4, so we've got the -3, and then it's to the 3rd power, which means you've got a -3 times -3, which is going to be a +9. And then a +9 times a -3, well, we end up then with a -27. So not all of the ones where you've got the negative in the parentheses are going to end up positive. Notice that for question number 2, we had an even number, where for question number 4, we had an odd number. So if you have an odd number, it's going to remain negative. All right, question number 5, again, just evaluate. 3 times 3 is 9. We're going to have the -9. All right, so now let's go on to a little bit more difficult ones where we're applying those exponent rules. So for our next one here, we're going to then take 8 times 3, just like you've always done, 8 times 3. Oh, you know, 8 times 3 is 24. And then let's multiply our exponents. Y to the 4th times y squared. Well, remember, when you multiply exponents with the same base, you have to add them. So I will have y to the 6th power. So I multiplied the 8 times the 3, and then I added the exponents for the variables. All right, for question number 7, now, because I can't take 4 divided by 3 evenly, I would probably just leave this as 4 on the top, 3 on the bottom. And then I would probably evaluate here and take x to the 6th divided by x squared. And so when you divide exponents of the same base, you subtract them. So 6 minus 2 is equal to 4, so I'd have x to the 4th. And this is all the further you can go ahead and simplify this one. All right, number 8. So for number 8, let's go ahead. You're going to multiply the 3 times the 2, and you get 6. And again, we're multiplying exponents with the same base, so we're adding them together, so y to the 5th. All right, so we have x squared divided by x to the 5th power. Well, notice, remember, dividing exponents with the same base, you subtract them. So if I minus a 5 right here, I'm going to have x to the -3 power. And remember, we don't want to have a negative exponent. To make a negative exponent positive, remember, we're just going to flip it, giving us a 1 on the top and the x to the 3 on the bottom. All right, for question number 10, first of all, let's just take a look at the numbers here. You have 5 divided by 15. Well, 5 cannot be divided evenly by 15. However, you can simplify, and so since they're asking us to simplify this, I know that 5 can go into 5 one time and 5 can go into 15 3 times. I'm going to just leave the 1 on the top and the 3 on the bottom. And then I need to evaluate x to the 3rd divided by x to the 6th power. So remember, when you divide exponents of the same base, you're going to subtract. So I'm going to take 3 minus 6, and I'm going to have x to the -3. Now, we need to make that negative exponent a positive exponent. So I'm simply just going to take just this part right here is going to be brought to the bottom. I'm going to leave the 1 on the top, and I'm going to have 3 and x to the 3rd. Because remember, if you bring a negative exponent to the bottom, that all of a sudden then that makes that a positive exponent. All right, question number 11. Let's take this as we're going to do everything on the top first, and then we'll deal with what's on the bottom. So if I take a look at this right here, I'm going to first start by multiplying 2 times 3. Well, 2 times 3 is 6. And x squared times x to the third, remember we add the exponents together, we have x to the fifth power. And now I'm going to divide that by 2x. I want to remind you that if you don't have an exponent, you do have one. It's a 1. So now, can we take 6 divided by 2? Yep, and I get a 3. Can I take x to the fifth divided by x to the first? Remember, you're subtracting them, so you will get x to the fourth power. All right, for this last one, I would like for you to pause the video. I'd like you to try this one, and then once you're done, resume the video and we can take a look. All right, so hopefully you noticed that you had 12 divided by 2. So when you combined everything, you had 12 x to the fifth on the top divided by 2 x to the fifth. Well, 12 divided by 2 got us a 6, but then hopefully you notice that x to the fifth divided by x to the fifth ends up being 0 exponents, which is actually equal to 1, and 6 times 1 is equal to 6. So hopefully for the answer you got 6.